Yes, class. We had started with Bernoulli's theorem. So this was the statement that pressure energy plus kinetic energy plus the potential energy, all the sum, it will be constant. So sum of all the energies will be constant. So total energy per unit volume is constant. So pressure energy per unit volume was P. Kinetic energy per unit volume was half rho V square, and potential energy per unit volume was rho GH. How it was rho GH? How it was this? This we had already seen. This is rho GH. This is rho V square by 2 like this. Now see, suppose I have, this is the horizontal level. Wait. This is the horizontal. Now I am taking a pipe of random shape, which has H1 separation from here and H2 separation from here. This is P1, here it's P2, area A1, velocity V1, area A2, velocity V2, diameter is D2, here the diameter is D1. This is the first end, this is the second end. Now we'll allow water to move. Fluid will be flowing through it. Now look, force at the first end, when we look at the first end, the force at the first end, F1 will be equal to pressure into area A1. Similarly, if we want to find out work done is force into distance. Distance is D1. All right, distance is D1. So we can say work done 1 is, what is F1? F1 is P1 A1 into D1. All right, if you want further, this is distance that we have taken. Let's say the time is T. So distance will be equal to speed into time. So how can we write this work done? This work done can be written as P1 A1 V1 into T. This is how we have written it for the first end. Similarly, for the second end also, we'll have the same thing. Work done second will be 2 will be minus P2 A2 V2, and time is, let's say this is T1, this is T2. Now why minus sign? Because work is being done in the opposite direction. Here, the distance was also this, force was also this. Here, the distance is this and the force is this. At the second end, angle is 180 degree. At the first end, the angle is 0 degree. So work done, net work done will be, they will get subtracted. So P1, A1, V1, T1 minus P2, A2, V2, T2. So whatever is the fluid entering at first end is equal to the fluid which is leaving at the second end. Whatever is entering from here is leaving from this side. So what can we say? We can say A1, V1, T1 is equal to A2, V2, T2. How do, this is the volume in time T1. This is the volume in time T2. All right. Now, when we are writing the work done as P1 delta V minus P2 delta V, we can take P1 minus P2 common, right? We can take P2 minus P2, PV delta V common. So what is this equal to? This is actually equal to the potential energy. All right, talking about the kinetic energy. Kinetic energy is half m V2 square minus half m V1 square. What will be the change in potential energy? mgh2 minus mgh1. What will be the change in potential energy? A pressure energy. This will be P2 delta V minus P1 delta V. This is the pressure energy. This is the potential energy. This is the kinetic energy. Look, work done is equal to kinetic energy plus the potential energy. So we can equate all of these. Look here. P1 minus P2 here. This is P1 minus P2. Delta V is equal to half m V2 square minus half m V1 square plus mgh2 minus mgh1. Let's just rearrange the terms. I'm just rearranging the terms. Or let's do one thing. Let's open this bracket. Let's multiply it with delta V. This also with delta V. So we get P1 delta V minus P2 delta V is equal to half mv2 square minus half mv1 square plus mgh2 minus mgh1. Now look, can we relate it? See, P1 delta V is the initial pressure energy. Half mv1 square is the initial kinetic energy. mgh1 is the initial potential energy. P2 delta V, this is the final pressure energy. This is the final kinetic energy, and mgh2 is the final potential energy. So we have pressure energy plus kinetic energy plus potential energy constant, because whatever is the initial quantity is exactly equal to the final quantity. All right, all these are equal to each other. This is how you can prove Bernoulli's theorem. This is the entire proof for the Bernoulli's theorem. This is how you have to calculate it. We'll see some questions also, but first write down the derivation. Okay, class done. Now see, one note point is it that says that if the height is same, see, we had taken a case where both the heights were unequal from the ground, right? This was h1, this was h2. If both of them are the same, so we will not include the potential energy component. Pressure energy will be there, kinetic energy will be there, but potential energy will not be there. Suppose the question says water is flowing through two horizontal pipes of different diameters which are connected together. In the first pipe, speed of water is 4 meter per second and pressure is 2 into 10 to the power 4. Calculate speed and pressure of the water in second pipe. Diameters are given. Look, P1 plus half rho V1 square is equal to P2 plus half rho V2 square. P1 is given as 2 into 10 to the power 4, right? Density of water, we already know it's 1000 kg per meter cube and velocity is 4 meter per second. This is already given. So when you substitute 2 into 10 to the power 4 plus half rho V square we have now. So plus half rho V square. This is equal to P2 plus half rho V2 square. Now we do not know two things. We have no clue about both the things. One thing that we know is the equation of continuity. Do you remember the equation of continuity? That said A1 V1 is equal to A2 V2. This is the equation of continuity. That is area into velocity will remain constant. So how can we write area? Pi r square, and radius can be written as half of diameter. So pi r square, that is half of diameter, into V1 is equal to pi d2 by 2 whole square into V2. Pi will be cancelled. This 4 will be cancelled. So we will be left with V2 is equal to d1 square V1 by d2 square. V2 is equal to 9 into 4 by 36, which is 1 meter per second. This is 1 meter per second. So now 28,000, the equation which we had left where P2 was missing. We didn't have any clue about V2. Now we know V2 is 1 square. So we can directly write this as P2 will be 27500 pascals because this becomes 500. And when you subtract 500 from here, this will be 7,500. So this much of pascals will be this. Write it down, then we'll see some applications of Bernoulli's theorem. Quickly write it down from here. Okay, now coming to the applications of Bernoulli. So first is the application of an aerofoil lift. Aerofoil has this shape, a streamlined kind of shape. This is an aerofoil. All right. So these are the layers of the fluid above and below. So basically here the pressure is P1 which is acting, pressure is P2 which is acting, which is lifting this up. Pressure is inversely proportional to velocity. So when pressure increases, velocity decreases. P2 is greater than P1. So net pressure is P2 minus P1. So force is equal to P2 minus P1 into area. This is how you'll be using. Second is the case of an atomizer or sprayer. In case of atomizer or sprayer, basically there's a bulb. Bulb is connected to through a narrow section to a broader section which has the fluid. And towards the end, so here you have the liquid, but when it comes out in the form of vapor. So atomizer or sprayer works like this. So when the bulb in the atomizer is squeezed, this is the bulb. Air rushes through the narrow neck of the atomizer. This reduces the pressure in the narrow channel so that the atmospheric pressure pushes the perfume up the tube leading to the narrow channel. The perfume is then dispersed into a fine spray of droplets. Last is blowing off roof in wind of summer. Like this. These are the very light roofs. So when wind blows with the high velocity, it causes the lowering of pressure. You just have to remember that pressure is inversely proportional to velocity. That's it. So when the high pressure of the wind has high pressure is blowing, it pushes this roof off. So if the wind blows fast enough, the internal air atmospheric pressure can blow off the roof. One numerical we have for this. First note down this, then I'll discuss the numerical. Then that will complete Bernoulli's theorem at least. An aircraft has a mass of 3.3 into 10 to the power 5 kg. Total area is 500 meter cube. Speed is 960. So we have to find out the pressure differences and fraction of speed which has increased. See, mass is 3.3 into 10 to the power 5 kg. Area is 500 meter square and velocity is 960 kilometer per hour. So for the first part, force is equal to P2 minus P1 into area. So F is equal to mg. Now see, mg is equal to P2 minus P1 into area. Basically, see, gravitational force is pulling it down, but the pressure energy, this is pulling it up. That's why this is stable. Understood? Now see, what is P2 minus P1 equal to? P2 minus P1 is equal to mg divided by the area. So this is 3.3 into 10 to the power 5 into 10. Area is 500. Fractional increase is equal to, when we are talking about the fractional increase, this is equal to delta V by V average. This you have to calculate whenever you have to calculate the fractional increase. So this is V1 minus V2, which is the divided by V average. So V average, when we are calculating, this is 960 kilometer per hour. So that will be, if 960, whenever you have to convert anything into meter per second and it's given in kilometer per hour, always multiply by 5 by 18. So we get 800 by 3 meter per second. Now you start applying Bernoulli's theorem. That is P1 plus half rho V1 square. See, it's at the same level, so we'll not be calculating the potential energy. That horizontal pipe case, rho V2 square. So P1 minus P2 is equal to half rho. So it will be V2 square minus V1 square, because this V1 will come here. And if you take half rho common, so it will be V2 square minus V1 square. Now look, P1 minus P2 half rho. One thing we can do you remember the identity A square minus B square? How do we write it? A square minus B square. Yes, Nuha, do you remember? A square minus B square.
Uh,
This identity, A square minus B square. A plus B into A minus B, okay? This is A plus B into A minus B. This is how we write it. Now you will remember, Nuha and Khadija, both of you. So see,
yes, ma'am.
this can be written as V2 minus V1 into V2 plus V1. Now, this V2 by V1 divided by this 2. This is exactly the average energy. This is the V2 by V1 by V2. This is the average velocity. So when you will write it, P1 minus P2 is equal to rho V2 minus V1. And what was left? V2 by V1, V2 plus V1 divided by 2. We'll just write it as V average. So P1 minus P2 divided by rho is equal to V2 minus V1 into V average. This is how we have to calculate. Now you can just substitute in the values. You will get the final answer. Write down the solution. Now we'll start with a different topic. Just one last topic is left. One last section. This is left, Toricelli's theorem. Note it down. Okay, so Torricelli's theorem basically says that this is also known as law of efflux, which basically says that in short, I'll tell you that velocity through the orifice will be under root 2hg. That's it. See, suppose this is a container and this is a very small orifice. Orifice means a very small hole has been dug in. So velocity through this becomes under root 2hg. See, if I apply Bernoulli's theorem, so P1 plus half rho V1 square plus rho Y1, right? Because of this, then for second one, for this point, for second one till the water level, it will be P2 plus half rho V2 square plus rho G Y2. Half rho V1 square is equal to P2 plus half rho V2 square plus rho G Y2 minus rho G Y1 minus P1. So A1 V1 is equal to A2 V2, where V2 is equal to 0. Why? Because this is at rest, this is not moving. Now, if this is at rest, half rho V1 square is equal to P2 minus P1 plus rho G Y2 minus Y1. So V1 square will be equal to 2 by rho, this 2 by rho, right? And this is P2 minus P1 plus 2 by rho into rho G. This is Y2 minus Y1. What have I done? I've just multiplied this here. Just I've excluded V1. So what is V1? This is V1 square. So V1 will be 2 by rho P2 minus P1. See, this will be cancelled. This is the height. So this becomes 2GH. This entire is this. And if both the ends are open, see both the ends are open, then P2 minus P1, this will be equal to the atmospheric pressure. Then you will have velocity equal to under root 2GH. Why? Because then this term will be 0 in case of both the sides are open. That's it, what you have to remember. See, if this question says that a drum of 30 centimeter radius has capacity of 220 decimeter cube of water. It contains 198 decimeter cube of water and is placed on a solid block of exactly the same size. So we have to find the water and the range. Range means from the projectile motion. See, how will you calculate this? Velocity will be under root 2 GH. So this will be under root 2 into G will be 980 centimeter, height is 70 centimeter. So whatever you will get this much centimeter per second. And range of motion, this is the first part, this is the second part. Range of motion is from the that projectile motion. So U under root 2 L by G. This is the formula, general formula from projectile motion. Just remember that L is the length of the container. Okay. And when you are calculating the volume as pi r square L, from here you know the volume, so you can find out the value of L. Because you know this is, and radius also you know it's 30 centimeter. So such types of questions also you'll be able to manage. You just have to put in the values of this. Note it down, quickly note it down. Last is Venturimeter. It's the device which is used to measure the rate of flow. So it's also based on Bernoulli's theorem. Basically, you have two pipes which are connected to through this U-shaped tube. So here the fluid flows and here you have the mercury. You don't have any derivation here. You just have to remember this formula, that the formula of V1 is 2H density of water into G divided by rho A1 square by A2 square minus 1 under root. This is the density of the liquid. This is the density of the liquid. All right. For example, if I show you one question also, this one. Here, the flow of blood in large arteries delivered through Venturimeter. Wider part has the area of cross-section as 8 millimeters square. Narrower part has 24 meter. You have to find out the speed. So see, you will be using the A1 is given as 8 millimeter square. A2 is given as 4 millimeter square. P2 minus P1 is given as 24 pascals. Density is given as 1000 kg per meter cube. So what is V1? So V is equal to under root 2 P1 minus P2 divided by rho A1 square by A2 square minus 1. So when you substitute in all the values, you will get the velocity's value as 0.125 meter per second. That completes your fluid mechanics also. Just quickly write down this Venturimeter part. Then we'll be starting with the next lesson in the next class.